Welcome back. This is Sunny again from Three-Phase Power. Just wanted to show you here how the VACON 100 flow runs as an example for a pumping application where the drive is actually the pump controller. We have set it up currently. I just wanted to show you here the drive demo. So this is the VACON 100 flow demo. I wanted to show you the different parts of it. This is the drive itself and the keypad. This is the digital inputs that we have, 6 of them. We have a couple of analog inputs here, a motor that will be spinning shortly, and an analog output gauge here. On the keypad here, on the screen, I want to show you what it's programmed for, so that when we run it, you'll understand how the keypad and what it shows. Currently, we have output frequency of 0, the drive is not running. We have a 80 psi set point that we want to maintain pressure at 80 psi. The PID feedback is 0 psi, but we can change that with the analog input too. You'll see that shortly. The status of the PID control is stopped. This will tell us if we're soft filling pipes at the beginning. It will tell us if the drive is sleeping. You'll see that shortly. Motor current, this is a very small motor, so the current will be fractional. DC link voltage, this is very important feature to have and display constantly on the keypad because we want to know what the line voltage is. So DC link voltage is fantastic. This slot A digital input 1, 2, and 3. We have off, off, and off. This is the first 3 digital inputs that are being monitored. So whenever one is on, if we have a selector switch, a handoff auto, we can utilize digital input 1, 2, 3. And the drive will tell us which one is on and off. Fantastic for troubleshooting, letting you know that your selector switches are actually working or not. And as we do the start command with digital input 1, we'll see the status from off change to on. And it's very great for troubleshooting at any time. The next one is power on time. So this is a elapsed time meter. It'll tell you how long the drive has been running for. It's a fantastic thing. Flushing. We have set up the second digital input if you want to flush the lines at a predetermined frequency. No matter what the drive is running, if you have a selector switch that says flush the lines, we can see how this is going to run shortly. So this is an example here. Let's go ahead and run it and see what happens. So right now we have 0 psi feedback. The lines are empty. So we want to start the motor and see how it goes. So we're going to give it a start command here. So the motor is starting to run. We still have 0 psi and PID status says soft fill. So we're soft filling the pipes at 31 Hertz until we reach to a predetermined level. So we're going to keep increasing the feedback until I believe that was 25 psi. And after 25 psi, we go to 60 Hertz. PID loop starts taking over. So we're running at 60 Hertz. It says PID status is running. Our set point is 80 psi and we see 33. So let's go over 80 psi. So our pressure transducer feedback is climbing, climbing, climbing. We're going to go above 80. So when it's above 80, then the speed starts slowing down. And then we have programmed the drive below 35 Hertz to start a counter. And this counter in our case is about 10 seconds, but to put the drive to sleep. This timer can be any number of seconds that you like. But we want to know when the pressure is too high, when the drive is no longer needed. After a few seconds, the drive will go to sleep. And we're going to demonstrate this shortly. So the speed is slowing down, 39 Hertz. Minimum speed, I believe, for this application is 30 Hertz. So at 35, it went down, so the timer now starts counting. And then we're going to put the drive to sleep shortly here. Here, the drive is asleep. So when the drive is asleep, it's no longer needed. The pressure is too high. Now we want to drop the pressure below 60 psi in order to wake up the drive and have it run again. But if the pressure falls below the 25 hertz of the soft fill mode, it will actually try to soft fill when it wakes up again. So there is no water hammer. We can demonstrate this by dropping the pressure, and now the drive is running. It's ramping up to 60, and the pressure feedback is 40 psi. Now, while we're running here at 60 hertz, if we want to flush the pipes, we can activate a second input, and this is activating the flushing sequence of the drive, which runs at 40 hertz until we want to stop it. So it doesn't matter what the drive is doing. When we activate the flushing sequence with another digital input, it overrides whatever we're doing. So it's really, really good that way. So you can see both of the digital inputs are on. So it's really, really good. Now, we could turn off the drive and let it finish flushing, or we can shut off the flushing, and then the drive will slow down to 0 because the run command is off. And we're gonna reset everything back to 0 psi.